In this era, the amount of user-generated data content online, such as review, comments, and social media posts, increased significantly, and the data should provide valuable information about the public opinion, experiences, and preferences. These are important for Malaysia because, as a major tourist destination in Southeast Asia, we receive nearly thousands of visitor reviews through platforms such as Google Maps. These reviews contain important information about visitor satisfaction, service quality, and the overall travel experience. Next, I'll explain about the machine learning model selected, which is BERT. BERT is a bidirectional attention mechanism, which means it can capture both left and right context of each word simultaneously. It makes it capable of capturing the linguistic meaning and context of the review text effectively. In this project, we use the BERT-based uncased variant. The key characteristic is that it contains 12 transformer layers. It has approximately 110 million parameters. It converts all input to lowercase and removes the accent mark during preprocessing. So it has the advantages for this project, which means it is suitable for informal Google Map reviews, provides better generalization on textual data, and it requires lower memory usage compared to the larger BERT model. For the BERT model training process, we first loaded the BERT-based uncase from Hugging Face into Google Colab. Then the dataset split into 80 training and 20 validation sets using stratified sampling. The review is then tokenized using BERT tokenizer with maximal sequence length of 128 tokens, and the padding and truncation is applied. It is then split into batch size of 16 sample. The model is also fine-tuned. Then the learning rate scheduling, backpropagation, and gradient clipping is applied to ensure stable training and reduce overfitting. The model with lowest validation loss is safe at checkpoint, and the training loss, and validation accuracy is plotted for performance analysis. This is the classification report of bird sentiment model. So you can see it shows an accuracy of 0.875. This is the confusion matrix of bird sentiment model. Overall, the bird model performed very well on positive review and reasonably well on negative reviews. However, the neutral class remained the main limitation of the model. Future improvement could include collecting more neutral reviews or apply techniques such as oversampling and class weighing to reduce the effect of class imbalance and improve the overall micro F1 score.
For our second model, we use a lightweight 1D convolutional neural network, or known as CNN. It has around 1 million parameters, therefore significantly smaller than BERT. CNN also effective for text classification tasks because it are able to capture local n-gram features from the sequence of token embeddings, therefore helps the model to capture the sentiment bearing phrases uh, irrespective of their position in the text. Also, since CNN has 1 million parameters, which is much more fewer than BERT, CNN is practical for deployment in a streaming pipeline. Also, CNN can use significantly less memory and computation, therefore the inference process should be performed continuously with low latency. And then the CNN operate efficiently over CPU for real-time inference because the use architecture prevent overfitting while the embedding layer was trained from scratch, therefore making CNN ideal for real-time deployment. We train CNN up to 10 epochs with early stopping using Adam optimizer and a patch of size 16. This graph shows our CNN's training behavior across 5 epochs. You can see the training loss drops consistently, but the validation loss starts rising from the epoch 3. So the training loss is the blue one on the left graph, and while the validation loss is the orange line. This is a clear sign of overfitting. Early stopping kicked in at epoch 5 and restored the best weights from epoch 2. Validation accuracy stabilized around 82% from epoch 2 onwards, meaning the model reached its learning capacity quite early. Here are the test set metrics. The CNN achieved 81.51% overall accuracy with a macro F1 of 0.5261. It performed strongly on positive reviews with an F1 of 0.91 but struggled with negative recall of only 0.1, meaning it missed 90% of true negative reviews. This is directly caused by a class imbalance where negative reviews make up only 8% of our dataset. The confusion matrix confirms this. Out of 507 positive test samples, only 474 were correctly classified, shown by the dark cell at the bottom right. However, for negative reviews, only 5 are out of 52 were correctly identified. The majority were misclassified as neutral or positive. Despite this, CNN was chosen for pipeline deployment because of its speed and low memory usage. Here comes the comparison between the model that we are going to choose. In the table that shows here, it is the comparison between BERT model and CNN model. So even if BERT's performance exceeds CNN on all evaluation metrics like accuracy, macro precision, macro recall, or even macro F1 score, CNN is chosen due to its trade-off between classification and low resource consumption compared to BERT's high memory usage and its 110 million parameters.
We designed a system with two parallel workflows, a real-time streaming pipeline and a batch processing pipeline. Both use the same CNN model for sentiment classifications, so the predictions remain consistent. The entire system is containerized using Docker, making it easier to deploy. First, the producer reads each review from clean CSV file and sends it to Apache Kafka as a JSON message containing the review ID, text, and timestamp. To simulate real users' submission review, we added a 0.3-second delay between messages. We also implemented a retrain mechanism so the producer can reconnect automatically if Kafka is temporarily unavailable. Next, Apache Kafka receive and manage the message stream while Zookeeper handle Kafka metadata. We also conclude an initialization service that automatically creates and retires Kafka topics when the Docker container starts, so no manual setup is needed. Next, starting with the streaming pipeline. Streaming consumer continuously listen for new messages from Kafka. Instead of processing uh, one review at a time, it group every 10 review in a small batch before passing them to the CNN module. This improves efficiency while still keeping the system near real time. The model predicts the sentiment, map the output back to negative, neutral, or positive, and then send the result to Elasticsearch. Overall, the system processes around 3 to 5 reviews per second, with an end-to-end latency of less than 1 second. Batch pipeline works differently. Instead of using Kafka, it reads the entire clean dataset and processes all 3,242 reviews in one run. Besides generating predictions, it also evaluates the model by measuring processing time, throughput, memory usage, and classification accuracy using the ground truth tables. Before each run, the batch index in Elasticsearch are recreated to ensure the result remain clean and consistent. Finally, both pipelines send their results to Elasticsearch for storage. Streaming prediction and batch results are stored in parallel index, making them easier to manage. Kibana then visualizes these results through a dashboard, allowing us to monitor sentiment distribution, pipeline performance, and model accuracy in real time.
Here shows our key findings on our project. It vitalized the sentiment diffusion, model performance, batch versus streaming throughput, and then the resource usage and most frequently discussed topic. So our pipeline was successfully run in both batch and streaming modes. The Kibana dashboard reported an average accuracy of 0.886 across both modes, both batch and streaming modes. Batch achieved a higher throughput of around 126 records per second, while streaming achieved 115. One thing to note, the overall sentiment distribution in the dashboard shows negative as the highest at 47%, which doesn't reflect our actual dataset. This is due to duplicate records accumulating from multiple stream pipeline runs during testing. Our Kibana dashboard has 8 panels. The donut chart here with the green, blue, and pink slices shows overall sentiment distribution. The metric card here at the top left displays average model accuracy, and then the tag cloud here that shows many words here, many keywords here, highlights the most frequently mentioned phrases like "it is beautiful place" and "diving paradise" and a lot more. And then here there's a group bar chart act as a visual confusion matrix comparing sentiment by text length. The line chart here then tracks sentiment trends over time. You can clearly see the batch pipeline as a single spike and the stream as a gradual spread over 60 minutes. The last two panels compare batch versus stream throughput here down here at the at the bottom of this page you can see these two uh, these two different charts. The first one is the panels compare batch versus stream throughput, and the second one is the CPU usage. Our team got many insights, so much insight as the result of this project. So I will summarize it. First, Malaysian tourist sentiment is genuinely positive. 78% of reviews were labeled positive, supported by the tag cloud showing phrases like beautiful place, amazing experience, a tourist heaven spot, And then second, class imbalance is our biggest model limitation. Accuracy looks good at 81%, but the macro F1 of 0.53 reveals the CNN cannot reliably detect negative reviews. Third, batch and streaming serve different purposes. Batch is better for one-time high-throughput processing, while streaming enables live monitoring with time-distributed records in Kibana.
Now we will talk about the optimization and comparison section. The suggested optimization are knowledge distribution and model quantization, Kafka partitioning and consumer group scaling, elastic search bulk indexing, and asynchronous processing. The expected result of optimization is lower memory consumption, faster inference, better classification performance, higher throughput through parallel processing, and improved scalability. Lastly, reduce network overhead and improve indexing throughput.
To conclude, we successfully built a real-time sentiment analysis pipeline using Kafka, CNN, Elasticsearch, and Kibana across 3,242 Google Maps reviews. CNN was deployed for its speed, around 115 records per second streaming, and then there's 136 for batch. The dashboard confirmed Malaysian tourist sentiment is predominantly positive, while the key limitations are CNN's low negative recall and duplicate Elasticsearch records. As for the future work, we include this bird for better accuracy, as mode for class imbalance, and expanding to multilingual data and more platforms. That's all from our group shopping. Thank you.